So I start this third video, means next video, which was actually illustration in page 65. Okay, we had last studied properties, means we have studied last distribution function or cumulative distribution function. Okay, now we will be seeing how this distribution function, we have already seen that how this distribution function is implemented when we were taking the problem of tossing two coins simultaneously. Okay, now we will be seeing how this distribution function works when we are actually toss a dice. Okay, let us toss a die and we will see how this particular probability means distribution function works. So page 65, all of you, let's start reading from there. Let capital X be a random variable denoting the number of points appearing in a toss of dice. Okay, it is written as die, you can also call it as dice, D-I-C-E. The distribution of X is, it is written over there, how it is distribution. Let us first write down the distribution of capital X. That is equal to how many, what are the spectrum points? It can have 1, 2, 3, 4, 5 and 6. Now let us write down the probability mass functions, okay, PMFs for them. Each can appear, means there are 6 outcomes and each value can appear 1/6 times. Okay, so it will be 1/6, this is also 1/6, this is also 1/6, this is also 1/6, this is also 1/6 and this is also 1/6. Okay, now if small x, now let us calculate the cumulative distribution function for this. So when I have not started tossing the die, that means what? My p of x is equal to 0. So how will I write it? If small x1 is less than 1, means this situation when I have not started tossing the dice, okay, then I have my distribution function fx is equal to p capital X less than equal to small x, that is equal to 0. This situation when I have not, there is no tossing, no outcome. So this fx is equal to 0. You can also use this term p capital X less than x is equal to 0. Now I keep my 1 in the lower bound. Okay, so let us first write down the lower bound now. If small x is less than equal to 1 and greater than 2, what will happen? Fx will be equal to p, again capital X is equal less than x sign, so p, I'm just writing it in short, capital X is equal to s small x, that is equal to f1, that is equal to 0 plus 1/6, that is equal to only 1/6. Now let us use this as my lower bound. If 2 less than equal to x greater than 3, so fx will be what now? My p, again capital X less than equal to small x is equal to f2 now, f1 plus f2, f1 plus f2, that is equal to what? 1/6. f2 is also, f1 was 1/6, f2 is also 1/6, so it is 2/6. Similarly, there is no space now. If now next bound is 3 less than 4, so again fx is equal to, what will it become? 1/6 plus 1/6 plus 1/6. Okay, f1 plus f2 plus f3, that is equal to 6, then half it will become, and so on. So let us write down the cases over here. It is also written over here. Let's start reading out now. So fx is equal to 0 when x is less than 1 and greater than minus infinity. That is equal to 1/6. I'm not writing it over here again because it's already written inside the, means I've explained you the technique actually. Now you have to read from the WhatsApp page. That is equal to 1/6 when x is greater than equal to 1 less than 2. That is equal to 1/6 plus 1/6, that is 2/6 when x is greater than equal to 2 and less than 3. That is equal to 3 times adding 1/6 when x is greater than equal to 3 and less than 4. Then 4 times adding 1/6 when x is greater than equal to 4 and less than 5, then 5 times adding 1 by 6, then x is greater than equal to 5 and less than 6, then 6 times adding 1 by 6, that is 6 by 6, that is equal to 1 when x is greater than equal to 6 and less than infinity. Then they have plotted in a graphical format, we don't need now. Okay, is this example clear? If you have any questions, if you have any doubts, you can please WhatsApp me, okay, in our group itself. Which portion is not clear, I will again explain it or make a separate video for that. So I go for my next example. Okay, it's also on distribution function itself. Cumulative distribution function is very important. So I've given, means I've explained 3 examples. Okay, it's not more than that is not required. So this is my last example. Just see, look, let us minutely study this example first. Let 3 balls be drawn at random from a bag containing 5 white balls and 3 black balls. Okay, so now let me, there are 8 balls, 1, 2, 3, 4, 5, 6, 7 and 8. Okay, among them there are 5 white balls. Say this is white, this is white, this is white, this is white and this one is white. The other 3 are black balls. Okay, these are the white balls, 5 are white balls and they are mixed together in a bag. So here now let us study that event. What will be my XV? Capital X denotes the number of white balls which I can draw. Okay, now this particular this bag contains these 8 balls. Okay, randomly they are arranged in a random fashion. Now I can at most draw 3 balls from this bag together, not more than that, even not less than that. You have to, your condition is you have to draw 3 balls randomly without looking at them. You have to draw 3 balls. Okay, now X is saying that what is the probability that these 3 balls will be white color. This is your event. So what is the problem? This is a bag. It contains mixture of black and white balls, 8 balls together, 5 white balls and 3 black balls. And the condition is you can only draw 3 black balls at a time from 3 balls at a time from the box or the bag. Okay. Now X defines what is the probability that the balls which I have drawn, means or the 3 balls which I have picked up are white color. This is the event. Okay. So how many values can X assume? X can assume such values 0, 1, 2 and 3. 0 when all the 3 balls which I picked up are black balls. This may be because I am not looking at the balls and picking them up. Na? So my hand can go to any particular ball. This is the condition when means the balls which I picked up are black color. So one white ball I picked up, that means the remaining 2 are black balls. 2 white balls I picked up, that means the remaining 1 is black ball, and 3 white balls I picked up, that means no black balls are taken. So these are my spectrum points, okay, or the sample points. Now we have to find out first we have to calculate the PMFs. Okay, first we have to calculate the PMFs and then we will go for distribution. X can assume the value 0, 1, 2, 3. So let us first calculate F0. F0 what it is? F0 means this condition. Let me write it over here. P capital X is equal to 0. That is probability of no white ball. Capital X is equal to 0, probability of no white ball. So what it will become? You know, permutation combination. We have already learned this in elementary classes. Okay. So 3 balls you have picked. The 3 are black balls. Divided by 8C3. Okay. I write it over here. 8C3. That will evaluate to, if you do combination, means if you calculate it, you will get 1 by 56. Okay. So 3C means 3C3 means factorial 3 divided by factorial 3. 3 minus 3 0. So you have to calculate it like this. Means the way you calculate combination, 8C3 means what? Factorial 8